Alright, we're going to be looking at example number 2 here from the notes. So as you can see, I already have the givens underlined, so let's write them out. So it says a car moving forward accelerates from a speed of 10 meters every second, so that's the initial velocity right there, to a final velocity of 20 meters every second in a time of 5 seconds. Oops, there's 0 there. Then the car later is backing up and slows from a speed of, so then we have a second initial velocity. And it says it is backing up, so we have make that initial velocity a negative 10 meters per second to a stop. So that's 0. It slows to a stop in a time of 5 seconds. Oops, seconds. So we need to calculate the acceleration here and explain why both A values end up being positive. But first, let's draw the motion map of the car's velocity for each of the situations, going there and then coming back. Alright, so with the motion map, let's start by creating a number line. Let's create a frame of reference, and from there we'll be able to start drawing our motion map. So here we go, let's start here. So car's moving forward, accelerates with a certain speed. We don't have any distance markers, so let's just start here. Let's say the car starts at this point right here. This is time equals 0 seconds. Okay, so the car is already moving forward from a speed of 10. So right now it has a velocity of 10, and it's going to be accelerating. So make sure we don't draw this velocity vector too long. There we go, right there. This velocity is 10 meters every second. Okay, so remember, when we draw the motion map, we are drawing, where did my vector go? We are drawing the velocity and position represented by the dot, at each second in time. So this is time equals 0. The next one will be when the time is at 1 second. So let's draw a position right there, and speed is going to be even greater right there. Okay. As time equals 1 second. Okay. Since it's going to be increasing, its speed from 10 seconds or 20 meters every second to 20 meters every second in 5 seconds. That means in each second it is increasing its speed by 2 meters every second. So if it's going 10 meters every second here, at the time equals 1 second, its velocity would be 12 meters a second. Maybe notice my vector is a little bit longer than this first vector. Okay. At time equals 2, the vector is going to be longer yet. The velocity will be 14 seconds because its speed is 2 meters per second faster than it was previously. The vectors might be a little bit too long here. Okay, should be longer than this previous one. This is time equals 3 seconds. Velocity equals 16 meters every second. Longer yet. Velocity is 18. Remember, I'm increasing by 2. Time equals 4 seconds there. And then at the very end, I'm going to be going off the page here. This velocity is 20 meters every second. At time equals 5 seconds. And this should match up. At 5 seconds, my speed is 20 meters every second. Okay, and then for the second motion map, it is it is backing up. So we'll be going to the left, and it slows from a speed of 10 meters every second to a stop. So here we go. So let's start right here. Okay, that's the position of the car at 0 seconds, and it's moving it from a speed of 10 seconds to a stop, and it's moving backwards. So we'll say to the left. So we'll say this is 10. V equals 10 meters every second. At 1 second, okay, since it goes from 10 to 0 in 5 seconds, that means that every second it's slowing by 2 meters every second. Okay, so at 1 second here, you don't necessarily have to write t equals every time. At 1 second, that's what that means right there. Its speed will be 8 meters every second. So let's draw that as a little bit shorter than the previous vector. Okay. 2 seconds. Vector will be even shorter. So we'll say this is 6. Shorter yet. This will be 4. That's at 3 seconds. 2 seconds. I'm sorry, 4 seconds. It's 4 seconds right there. Where are my lines going? This is 2 meters a second. And then at 5 seconds, my vector should have a length of 0 because I'm not moving. So it's 0 meters per second there. Alright, so now that we have the motion maps here, let's figure out the acceleration for each of these situations. So always start with your equation. We already have the givens. Always start with your equation with variables. So we have acceleration is equal to the change in velocity over time. We know that change in velocity is final velocity minus initial velocity. We'll divide that by time. We'll use this equation for both situations. Okay, and here are my givens right here. Just plug the numbers in. So here's situation 1. We'll call this acceleration 1. Final velocity is 20. Initial velocity is 10. The time it takes is 5 seconds. End up with 10 over 5, which is 2.00 meters every second squared, and this is your first acceleration. Okay. Alright, since we got the first acceleration, now let's solve for the second acceleration. We'll call it a sub 2. Okay, we'll use the same equation here. Final velocity is 0 minus an initial velocity of negative 10. So it's minus negative 10 over a time of 5 seconds. Add the opposite, you end up with 10 over 5, which miraculously is 2 meters every second squared. It is A2. So in both situations we end up with a positive acceleration. We end up with a positive acceleration. Why? Because in both situations the vehicle is accelerating towards the right. How can this be? Well, in the first situation, since we're moving to the right, or we're moving in the positive direction, and we're speeding up, that means we are accelerating into the positive direction. In the second situation, we're moving to the left, or we're moving in the negative direction, and we're slowing down. In the second situation, our acceleration vector, if I was to draw the acceleration vector, it would point to the right, because we're losing 2 meters per second of velocity for every second in time. So our acceleration will be positive here, as well as our acceleration in both situations. So remember, even though we're moving to the left, our acceleration can still be to the right.